Hello, my name is Michael Richardson. I am sharing a prioritization model I developed based on a persistent challenge in using one of the many models returned even by a casual web search. Here's a list of some of the prioritization models or techniques. Each one has associated pros and cons. Oftentimes, people end up using one technique or another based on what they have used in the past or using a technique that is recommended within a framework or process they are using, like using WSGIF when they are using SAFe as their reference for scaling lean agile ways of working. Yet, even with all these choices, I found myself in a situation where none of these techniques provided what I was looking for. I needed something that considered that not all jobs or defects could be ranked against each other. Even though the type of work was the same, I needed a model that would work when a collection of jobs, as a group, would move higher or lower in priority. As I explored further, I found that I could refer to the collection of jobs or defects as belonging to a class. The classification could capture the different benefits to a company or its customers. The core of the model is that it is classification aware, and the implementation of the model is such that no one classification excludes consideration or prioritization of work or defects in adjacent classes. The CAJR model is how I refer to the generic job prioritization model. Classification aware job ranking. I'll share more about the CAJR model, then I'll transition into a presentation of the classification-aware defect ranking model, which implements the CAJR model specifically for defects. The classification-aware job ranking model is a model I developed for using a job ranking score determined by classification tier and then applying an offset within that tier that is calculated by dividing the need to do by the effort to do. The classification-aware job ranking model may be used to prioritize work or jobs with an inherent tiering of priority levels, such as feature implementation for tiered customer levels like Diamond, Gold, and Bronze customers, responses to customer requests for API enhancements when you have tiered support levels, or initiatives for enterprise, mid-market, small, or medium business. You might also consider market segment tiers, geographic tiers, risk tiers, innovation tiers, whatever makes sense in your environment. In a flow-based enterprise solution delivery system, various work types have to be considered, with budget and capacity allocations applied to establish guardrails that ensure no one type of work is ignored. For example, it is essential to consider infrastructure, maintenance, and technical debt in addition to the constant desire for product enhancements. In a world where everything feels important and we constantly feel overwhelmed trying to stay on top of it all, it's critical to ruthlessly prioritize tasks and obligations based on their actual level of benefit to the enterprise. We need models to help us avoid the tyranny of the urgent. Using a job prioritization model that has sufficient fidelity, like the CAJR model, and considers typical prioritization factors enables you to say no objectively, or at least not yet, to those jobs with a lower calculated ranking score. Using a model-based calculation helps to remove the subjectivity from the conversation, and the fidelity of the ranking scores helps to avoid the constraint of a limited set of priority options like high, medium, and low, where you often end up with too many defects having a high priority. Weighted shortest job first, as popularized by SAFe, is often used to prioritize work for the best economic outcomes. For most jobs, you can consider business value, risk reduction, or opportunity enablement, along with time criticality to prioritize one job against another. However, as you have a variety of work types or job classes, there may be valid reasons for a job with lower cost of delay and longer duration needed for implementation to be prioritized over other jobs with a higher cost of delay and shorter implementation duration. The classification-aware job ranking model helps in this overlapping priority area while still supporting the intent of economic benefit. The numeric values used to capture class tiering and the components that are used to capture the need to do and effort to do are carefully considered to allow for a desired amount of ranking score range and the overlap between the tiers. The amount of overlap in the job ranking score between each class is an important characteristic of the CAJR model. This overlap helps to ensure that highly beneficial jobs that require a bit of effort from a lower class are not always deferred or ranked lower than less beneficial, easy-to-do work from the higher class. It is this overlap that provides for a single backlog rather than a separate class-based backlog. Recognizing that classification tiers, if strictly followed, could lead to the exclusion of any work in a lower class, we shouldn't allow one class, or pure economics, to dominate the ranking score, as that is likely to lead to undesirable outcomes for the business as a whole. The CAJR model provides for overlap in the job ranking scores to avoid hard-lined and exclusive prioritization. The ranking score distribution and overlap must be analyzed whenever the values used for the calculation are revised. As mentioned, the CAJR model has a specific implementation referred to as the classification-aware defect ranking model with a defect ranking score. The CDR model is used to prioritize defects to obtain the most beneficial outcome possible for the enterprise, customers, and internal stakeholders with the capacity that has been allocated for resolving defects. In the CDR model, the need to do is rephrased as the need to resolve, and the effort to do is rephrased as the effort to resolve to calculate the defect ranking score. The need to resolve is a measure of the consequence that exists if a defect remains in the solution. The effort to resolve is the time it takes to remove the defect from the solution. The time it takes to remove a defect is hard to determine because it depends on the team that will work on the defect and their knowledge of the solution's architecture, logic, and code. To make things easier, we estimate the effort to resolve using a general understanding of the solution as an inverse proxy for the effort to resolve. On average, defects take less time to resolve when the team has a high level of understanding around the solution's use, design, logic, and code base. Defects typically take longer to resolve when a team has very little understanding of these factors and has to explore and learn about the solution itself before they are even able to begin considering the causes and ways to resolve the defect. Defects that have the highest defect ranking score are those that can potentially deliver the greatest benefit in the shortest amount of time. Typically, less effort aligns with less time. Teams should work to resolve those defects, providing better benefit and customer satisfaction first, using the CDR model defect ranking score to prioritize defects within the backlog. Use the CDR model defect ranking score to continuously prioritize defects in the product backlog because some of the defects might have a due date for compliance or a promise to a customer, and the pressure to resolve changes with time. Working collaboratively with customer service and other stakeholders, product management manages the backlog in the prioritization process. The CDR model helps teams deliver defect resolutions that maximize benefits while consuming the least amount of capacity for those benefits. The CDR model gives preference to those defects that are well understood and can typically be resolved quickly. This avoids dwelling on defects that are not well understood and would cause a team to get stuck while other defects pile up and levels of dissatisfaction rise. The CDR model supports product development flow economics by ensuring that the smallest amount of capacity is used to deliver the greatest levels of benefit and satisfaction possible. The CDR model supports flow by scoring those defects that can be resolved over those that might become an impediment to flow. I started with an overview of the CAJR model and then briefly introduced the CDR model as a way to sequence defect resolution efforts based on delivering the greatest benefit and satisfaction in the shortest time for a backlog of defects. Additional videos in this series will focus on the CAJR model and include, as a PMPO, when should I use the CAJR model, understanding the defect ranking score formula, how to calculate the CAJR model defect ranking score, using Excel to calculate the defect ranking score, facilitating a CAJR workshop, and CAJR worksheet demonstration. For more information, visit my website at michael-richardson.com. And to implement the CAJR model into your ALM tooling, contact me.